Welcome to the Padhai Kar Lo JEE preparation channel. You can practice more problems on this exact topic on our Padhai Kar Lo Android app, link in the description below, or on our website padhaikarlo.com. Today's topic is nucleophilic substitution reactions and their stereochemical aspect. Let's begin. In an SN2 reaction, the incoming nucleophile genuinely attacks the electrophilic carbon from the side directly opposite the leaving group. In a single, concerted step, this backside forces the other three substituents to flip through like an umbrella turning inside out in the wind, producing a complete inversion of configuration at that carbon called Walden inversion. Because this backside approach requires open space SN2 reactions genuinely proceed fastest at methyl, non-primary carbons, get at secondary carbons, and are genuinely blocked almost entirely at bulky tertiary carbons, where the crowded substituents physically prive that backside approach. In an SN1 reaction instead, the leaving group departs first entirely on its own, forming a flat, planar carbocation intermediate, and only then does the nucleophile attack. In a separate second step, since that planar carbocation is genuinely attackable from either face with roughly equal probability, the product forms as a racemic mixture, near 50-50 blend of both inverted and retained configurations. Because carbocation stability is what actually controls this pathway, SN1 reactions genuinely proceed fastest at tertiary carbons, whose carbocations are stabilized by 3 electron-donating alkyl groups, the exact opposite substrate preference from SN2. Beyond substrate structure, the solvent genuinely tips the balance too. Polar protic solvents, like water or alcohols, stabilize the carbocation intermediate and favor SN1, while polar aprotic solvents, like acetone or DMSO, don't solvate the nucleophile as strongly, keeping it highly reactive and favoring SN2 instead. The nucleophile's own strength matters too. Present in high concentration, genuinely drives the reaction towards SN2, while a weak nucleophile favors Dis. There doesn't actually depend on the nucleophile's strength at all. The single most frequently tested G skill here is genuinely predicting the stereochemical outcome directly from the mechanism. Complete inversion for SN2 at a single stereocenter, versus a racemic, or partially racemized mixture for SN1. A frequently tested trap involves genuinely a secondary substrate, which can react through either mechanism depending on the specific solvent and nucleophile conditions given. Always check all the given conditions together rather than judging from substrate structure alone. Also remember that SN1 reactions are genuinely prone to carbocation rearrangement, a hydride or methyl shift that occurs partway through, whenever it would give a more stable carbocation, producing rearrange. Unexpected final product. Let's recap. SN2 is a single concerted step with backside attack, giving complete of configuration, and is favored by unhindered substrates, strong nucleophiles, and polar aprotic solvents. SN1 proceeds through a planar carbocation intermediate, giving a racemic product, and is favored by tertiary substrates, weak nucleophiles, and polar protic solvents, with a constant risk of carbocation rearrangement. Matching mechanism to stereochemical outcome is the key skill this topic tests. That's nucleophilic substitution reactions and their stereochemical aspects. Peer Clois thermal pe sahising paschimi Afriki Rendinavian Leonie way to handle stereochemistry questions on the exam. If this video helped, please like it and subscribe to Padhai Kar Lo for more JEE preparation content just like this. See you in the next one.